Good morning, children. And today we are going to complete the chapter. This is a very, very easy chapter. Of course, almost all the exercises are from the revision part only. And this is something new to you. Transversal. See, when a line meets a set of lines, not necessarily be only two, maybe three, four, five, whatever it is, set of lines, yet distinct points. At distinct points means at different points, then that line is called a transversal. So it should meet the lines at distinct points. So from the examples whatever given here, see this is a transversal. Why? Because it is meeting the two lines at two distinct points. Yes, this is also a transversal. It is meeting these two lines at two different points. This is a transversal here. This is a transversal. This is meeting these two lines at two different points, at distinct points. Now coming to this part. None of the lines are transversals here to any set. See, if you take this one, it is not meeting these two lines at two different points. So all have common points. So therefore this is not a transversal. This is not a transversal. So what is the basic condition of a transversal? It is not necessary that lines should be parallel. So any set of lines, however they are, if a particular line meets those lines at different points, then the line is called a transversal. Okay, children? So simple, straight. Only thing is just imagine. Okay. Next, angles made by transversal. So now here is a transversal. Let us name the lines as L and M. And N is a transversal. N is another line which is a transversal because it is meeting L and M at two different points. Right? Fine, fantastic. So here from the name itself we wanted to find out interior angles. Interior means between the two lines whatever angles are there made by the transversal. So those are called interior angles. So let us write the interior angles here. So what are they? Angle 3, angle 4, angle 5 and angle 6. So these are the interior angles which are between the two lines. Then it is very clear. Exterior angles means which are outside the two lines. So that is angle 1, angle 2, angle 8, angle 7. So these are the exterior angles. Means angles which are outside the two lines. Interior means angles which are inside the or in between the two lines. Right? These are the angles made by the transversal. These are the angles made by the transversal. Fine. Right. So now we are moving to the next part. Interior and exterior alternate angles. So how to identify them? So here are the properties. These three properties are important. You have to check these properties. If all the properties are satisfied, then only you can write a pair of interior or exterior alternate angles. What are these angles? Alternate angles. Of course, interior stands for inside angles, exterior stands for outside angles. So what is the term which you have to keep in mind? Alternate angles. This is very important, right? So now let us see the properties. What are they? First one, they should have different vertices. Okay, so that means one angle should be here somewhere, the other angle should be here. Suppose if you are talking about interior angles, then either this or this here, and here also either this or this. So first condition. Second one, are on the either side of the transversal. They should be on either side of the transversal and lie between two lines if interior. So now let us take the interior angle. This angle I am taking. Let us apply the laws. They should have different vertices. That means I have to choose another vertex. Now no more angle over here. When you are talking about alternate angles, when you have picked up one interior angle here, now leave this space and move on to the next vertex. And here at this vertex, again interior only we have to take. That means either this or this. And what is the second condition? They should be on either side. That means if it is on the left hand side, here it should be on the right hand side. Beautiful, na? So it's beautiful. So I'll write it as I, right? I1 is one pair. I1 is one pair. And what is the other pair? Suppose if I take this one, right? This is going to be the alternate interior. So I'll write it as I2, I2. So we have two pairs here. I1, I1, I2, I2. Okay. So now these are the interior angles. Alternate interior angles. This forms a pair. This forms a pair. I1, I1 forms a pair. I2, I2 forms a pair of alternate interior angles. Okay, children. Let us do the same with exterior angles. Okay. So if it is exterior angle, okay, I am choosing this one. E1. So let us pair it with another. What is the other one? We should leave this vertex, move to this vertex, and it should be on other side of the transversal and exterior angle. So this is the one which is satisfying it. So E2 exterior, I'm sorry, E1. E1 is paired with E1. Similarly, E2 is paired with E2. Did you get the meaning now? Alternate angles on either side. These are exterior angles. Okay, children, it is something like opposite. Okay, so take a screenshot of these things. So transversal examples. So angles made by transversal. First interior and exterior angles. And then this one, interior and exterior alternate angles. Here you will be talking about the pair of angles, right? So you have two pairs of interior alternate angles and two pairs of exterior alternate angles. Now next, corresponding angles. Let us see the properties. Okay? Right. Angles at different vertices. Okay, first condition is same. Even in alternate angles, we have seen the same. Or on same side of transversal, it is exactly opposite to the alternate angles. Alternate angles, they should be on either side of the transversal. Here in corresponding angles, both the angles should be on the same side of the transversal. Now, in the pair, one is interior and other is exterior. One is the interior and other is exterior. Okay, shall we start? Yes. Let me take one angle. So, I am taking one angle here. Okay. So, should have two vertices. Okay, one vertex is done. Which one have I taken? Exterior angle. What is the second rule? Should be on the same side. What is the third rule? If one is exterior, the other should be interior. See, beautiful. So, C1 corresponding first pair. Okay, so shall we see the other pair? Corresponding second pair. C2 corresponding second pair. We shall draw another diagram in order not to get confused with the other pairs. So now this one, I am taking here the exterior angle. Here is the exterior one. So on the same side, it should be interior. So these are the things. That means C3. Okay, so if I take this one as the exterior now, this is the interior. So C4. So that means in this case you have 4 pairs of corresponding angles. Is that clear, children? Any confusion? No, it's so simple. So before you start locating the pairs or pairing the angles, please give a reading to the properties. Okay, right. Take a screenshot here so that we can move to the next part. Right. The next one is interior angles on the same side. So no properties, nothing. The name itself is saying interior angles. Okay, this is interior angle on the same side. So this is another one. Okay, this is pair 1. First pair. What is the second pair? Let us This is the second pair. This is second pair. On the same side. On the same side. Okay. There is also an use for this one. So that is why we are defining. Unnecessarily we won't define now. So take a screenshot so that we can move to the next part. Yes. Now we are moving on to transversal and parallel lines. See, till now whichever lines we have seen, we did not take them to be parallel. We didn't specify them to be parallel, and you can also observe we didn't take them as parallel lines. Any set of lines. Okay, so they need not be parallel. But here now we are coming to completely parallel lines. So transversal and parallel lines. What are the rules that we have? Corresponding angles are equal. Each pair of corresponding angles are equal. You can't say that all corresponding angles are equal. So, pair of corresponding angles are equal. Now, let us look at the corresponding angles here. Okay. Let us name. So, corresponding angles, what is the rule that you have? Angles at different vertices or on the same side of the transversal, right? One should be interior, one should be exterior. So, therefore, I am taking one exterior here. So, let me name it as 1. So, the other corresponding angle should be interior on the same side. So, this is. So, here angle 1 is equal to angle 2. So, these two are paired. These two are paired. Right. Then next, other corresponding angles, let me take. This is 3. This is interior. On the same side, this is the exterior. 4. So, angle 3 is equal to angle 4. Okay, right. Now, let us see the other one. So, I am taking this one as exterior. The other one on the same side should be interior. So, this is interior. 5, 6. So, angle 5 is equal to angle 6. Now, I am left with one interior here. 7. This corresponding one should also be the interior here. I'm sorry, exterior here. It is 8. So, angle 7 is equal to angle 8. Now, can you see what are the pairs of corresponding angles? Yes, beautiful. No doubt at all. Very, very clear. We followed all the rules. Right. Now, each pair of alternate interior angles are equal. Yes, let us start pairing. Alternate interior angles. Okay. So, one is this one. Alternate means on the other side. This is the other one. So, both are paired. 1, 2. So, angle 1 is equal to angle 2. Right. And this is the other one. Other interior 3. This is 4. So, angle 3 is equal to angle 4. Angle 3 is equal to angle 4. Obviously, here though we didn't mention, but you can see that alternate exterior angles are also equal. This angle is equal to this angle. So, that is 5, 6. So, I am writing for that also. Angle 5 is equal to angle 6. And now this one. Angle 7 and angle 8. So, angle 7 is equal to angle 8. So, this is for interior angles. These two are interior. These two are exterior. Alternate interior and exterior angles are equal. This is only in case of parallel lines. See, remember children, suppose if the case is given like corresponding pair of corresponding angles are equal, then we can conclude that definitely the given lines are parallel lines. If they say that the given lines are parallel lines, you can equate the corresponding angles or alternate interior angles. So, either way, it is kind of vice versa. Okay? Right. Come on, screenshot this. So, now each pair of interior angles on same side are supplementary. Just now I said there is a use why we are specifying about interior angles on the same side. So, here what they are saying, each pair is supplementary. What is meant by supplementary? Sum of the angles is 180 degrees. Let us see that one, right? So, this is on the same side. This is a pair, is it not? 1 and 2. So here what is given? Angle 1 plus angle 2 is equal to 180 degrees. Angle 1 plus angle 2 is 180 degrees. And on the other side, 3, 4. So angle 3 plus angle 4 is equal to 180 degrees. So you can observe, see, this is an acute angle, this is an obtuse angle. Both together, when added up, according to the property, it is 180 degrees. Okay, right, take a screenshot of this. And also the conclusion. Suppose if above all conditions are satisfied, then the lines are parallel. If it is not given as parallel, but these conditions are given, then obviously the lines are parallel. If parallel lines are given, then you can apply these conditions. Let's do one example problem here. Okay, find the measures of x, y and z in figure when L is parallel to BC. So this is a line L which is parallel to the base of the triangle BC. These two are parallel lines. So therefore this is a transversal, is it not? If you extend the line, you can easily understand that this is a transversal. So in the transversal, if I extend this line also, you can see that these are alternate interior angles, is it not? So if AB is extended, then angle Y is equal to 75 degrees. Why? Because alternate interior angles. All the conditions are satisfied, no? On the either side of the transversal, inside, that is between the two parallel lines, is it not? At two different vertices. Yes. So we got Y. Right. Similarly, extend this one. Similarly, extend AC. Extend AC. It forms a transversal. Transversal. So therefore, again these two are interior alternate angles. So therefore, angle Z is equal to 45 degrees. Same reason. Alternate interior angles. Alternate interior angles. Okay, children. So we got already Y value. We got already Z value. Now x though we can determine from anything. See, this is a straight angle totally 75 plus 45 plus x is equal to 180 degrees. That one we can do. Or sum of the angles in a triangle is 180 degrees. Use that property and you can do that one. So in any manner you can find out x. Okay. So now let me take the straight angle concept here. Okay. So because we are discussing about lines and angles, I want to use that property. If it is properties of triangles, I would have used some of the angles of a triangle. Okay. So let me use that property. So from figure, 75 degrees plus x degrees plus 45 degrees is equal to 180 degrees. So now x is equal to 180 minus 45 minus 75. So 180. So add these negatives first. 5 plus 5, 10. So 5 plus 7, 12. 120, which is equal to 60 degrees. So thus, therefore, angle x is equal to 60 degrees. So we got all with reasons. With reasons. See, whenever you are dealing geometry, especially with the rules, whichever conclusion you are coming to, it will be depending on a particular rule. So it is a must for you to write just beside the equation or just beside the step based on which rule you are coming to this conclusion. That is what we call as reasons. Okay, take the screenshot of this. Let's see one more example. Yeah, this is from exercise 7, third problem. That's the last exercise from your lesson. So another problem which is very simple but looks as if it is tricky. Nothing is here. See, now he is asking us to find the angle A, angle B, angle C, angle D and E from the figure. Give reasons. So when you observe the figure, you just keep extending these lines. See? So these two form parallel lines. Parallel lines. Parallel lines. So these are all parallel lines, is it not? And these are parallel lines. Again, if you extend these lines, you can see that. You can visualize it very easily. So parallel lines. So that is what he gave in the note also. Two arrow marks pointing in the same direction represent parallel lines. Okay, done. So we have got parallel lines here. Now what is our job to find? Angle A, B, C, D, E. So solution. So from figure, right, angle A and 50 are alternate angles, is it not? Angle A and 50 degrees or alternate. See, if this is the line, alternate interior angles. Interior angles. Since lines of same arrow mark are parallel, angle A is equal to 50 degrees since alternate interior angles are equal. Interior angles are equal. Is it not? So in case of parallel lines, only when they are parallel we can write them to be equal. Okay? Right. So similarly, if you take now B and 50, same reason. Angle B and 50, same reason. Angle C and D, same reason. Angle E and 50, same reason. Right? So now, second one. So angle B. Similarly, this is a symbol for similarly. Angle B is equal to 50 degrees. Now, angle B is equal to angle C, which is equal to 50 degrees. Now, angle C is equal to angle D, which is 50 degrees. Angle D is equal to angle E, which is 50 degrees. Okay, children. So we are able to find out all. So therefore, angle A is equal to angle B is equal to angle C is equal to angle D is equal to angle E is equal to 50 degrees. This is the conclusion. Take the screenshot. So with this, I'll end the class. Try to finish all the problems from the exercise. With this, the chapter is completed. So do all the problems and post me your doubts.